Hello and welcome to this demonstration video for Phi 204 and Phi 242. And this is going to be the introduction to our electronics kit. And I wanted to let you see exactly what it is your kit should include and the things that we're going to use. Now, when you first initially open up your kit, this particular piece of circuitry should have been connected to your breadboard, and you can literally just pull it right out. Okay, so we're not going to bother with that particular piece, nor are we going to bother with this particular set of rainbow set of wires here. You don't need that. At least for the moment. Also, you should have a set of LEDs, and we won't be using those either. Okay, what we're really after are the sets of resistors, which would have come in these two packs, right? And which I've got laid out here, here, and here. And these jumper cables. And you should have also obtained a case of capacitors. Okay, so the resistors and the capacitors are the dominant things that we are going to use for our investigations. Okay, now I also had you buy two multimeters, and I'll explain why here very shortly as we move through. And I also had you buy multiple battery holders, in fact 8, and we will use all 8, but I'm only going to demonstrate the first experiment with 2. Once you do the experiment with 1 and 2, then it's no problem to hook up 3 through 8. All right, but you will need 8 D batteries as well. Okay, now so what we're going to do is I'm going to take one of the resistors from the 100 ohm package here, all right, and one thing that we need to note, all right, and the breadboard is where we're going to build our circuits. Okay, the breadboard is how we're going to build our circuits, and one thing you'll note is that your breadboard has 2 columns on each side, one on each side, I guess I should say, that is labeled red, and that is your plus column. That is the column that you will connect to the positive terminal of your battery. And the blue column is where you'll connect to the negative terminal of your battery. Okay? So I shouldn't say get, I would say become familiar with your breadboard. Now, one thing that you'll want to know how your breadboard is put together, the non-red or blue columns in the middle here are where you're actually going to place your resistors and your jumper wires and so on. And these are wired such that they have strips of metal that go across. Okay, so if you place things in the same row, okay, then be sure that there is one end of your circuitry that then goes to a different row, or else you'll be shorting out your equipment. Okay, and we don't want to do that. So be sure of that. And we'll show you step by step how to set this up. So don't fret, right? Don't fret. So let's actually start to jump right in. So what we're going to do is we're first going to hook the battery to the breadboard, and we're going to do it with the gator clips and these jumper cables. Okay, so your jumper wires come in 2 lengths. One length is a little bit longer, and then there should be several that are on the short end of things. All right, and so we want to use the short jumpers. So the first thing first is to take a wire, and you want to place it in the top slot of the plus sign. All right, you want to place it in the top slot of the plus sign. Okay, and your breadboards are going to potentially get a little messy here, so we want to make sure that we understand exactly what's going on and build things cleanly. All right, so actually I'll tell you what. Okay, so we're going to leave that jumper as is. All right, by the way, I should also mention this: your rows in between your red and blue rows are wired across, but your rows up and down are wired down. Or I'm sorry, your plus and minus are wired up and down. Okay? So what's going to happen is eventually we're going to connect a cable, a gator clip here, to our battery, and this is going to supply power to the breadboard. Okay? And then I want to connect that positive terminal power to the breadboard itself. So I'm going to do that with a second jumper. I'm going to put it in the second column underneath, or I should say the second row underneath, and then place it on the next slot, but in the actual circuit area. Okay? So your breadboard so far should look like this. So what's going to happen, we're going to connect a gator clip to the positive terminal. That is going to supply the current to the breadboard. That current is then going to flow down the positive strip into this jumper and take it to the circuitry area. Okay? So now we want to take our 100 ohm resistor and place one end in that same row, any slot in that same row. Okay, any slot in that same row, and then we want to bend it over and place it in essentially any row beneath it. All right, but it's okay if you want to stretch it out so that way the breadboard won't get so convoluted in one area, but you do want to make sure that you can make a secure connection. Okay, so whatever slot you put it in, you want to make sure it's going to make a secure touch. Okay, so now my breadboard looks like this, and at this point I'm going to take another jumper, put it in the same row as the bottom of the resistor, and you do want to make sure that all of these are pressed in. Okay, and then I want to put a jumper on the negative terminal. Right, so now your breadboard should look like this. Okay, so I'm going to have power coming in. It's going to go through the positive strip into the white wire. The white wire is going to supply it to the horizontal strip that goes across, which is then going to feed the resistor. And the resistor, the current's going to flow through the resistor, then into this jumper. And I'm going to leave a gap here because this is where we're going to put our ammeter. Okay, we're going to put our ammeter here, and then we're going to put one final jumper on the negative terminal, and this is what we're going to connect to the battery. Okay, this is what we're going to connect to the battery. All right, so It looks a little convoluted, it looks a little complicated, but once you get the hang of this, it'll become more intuitive as we go along. Okay, so you've got your positive terminal coming in, current going through the white into the resistor. Through this, the current will then go through the ammeter into the black jumper, and then back out the orange jumper back to the battery, which will then complete the circuit. Okay, so now to connect the battery, you'll notice that the battery holders have these little clips. Okay, what I would do is actually just kind of bend the clip up just a little bit. Okay, so without bending the clip up, you have just this little tiny area to grip, but if you push the clip up a little bit, you can really get the gator clip on there. Okay, so I've connected this to the negative terminal, so I'm going to then connect this jumper to the negative terminal here, right? And I'm then going to take this jumper, or a gator clip rather, and same thing, I'm going to push the tab down, make a secure connection, and connect that to the positive jumper there. Okay, so now we're at the point to insert our multimeters, and I want to take a few minutes to explain what's going on here. So your multimeter came with two cords, a black one and a red one. Your black cord, all right, should always be plugged in to this port labeled COM. Okay, so this is the port that is grounded. This is the port that acts as your 0 voltage. Okay, and so that should always go here. At this point, you have a choice whether you're going to measure voltage or current. If you're going to measure voltage or resistance, you want to put your red sensor in the second slot, which is labeled V omega MA. Okay, and if you're going to measure high amounts of current, then you would want to put your connection up here. But almost all of our measurements are going to be in the milliamp or smaller range, so we can get away with this. But the reason that I had you buy two multimeters, okay, you'll notice your dial has voltage, and the voltage with a solid line means DC voltage. So anytime you would flip your ammeter over into this corner over here, it's going to try and read DC voltage, right? And you have different scales. So if you're really reading very small amounts of voltage, you would set it on the 200 milliohms, or 200 millivolts, 2000 millivolts, which is 2 volts, 20 volts, 200 volts, or 1000 volts. And so you'll notice also when it's on that setting, you get the HV, which stands for high voltage. And so if I'm reading something that's on the range of 1 to 10 volts, I'm either going to set it on the 2000 millivolt range or the 20 volt range. Okay? The V with the squiggly line means AC voltage, which is the kind of voltage that's coming out of your outlets, right? The A with the solid line means amperage. And so these are your amps. 200 microamps, 2000 microamps or 2 milliamps, 20 milliamps, 200 milliamps, or high amperage up to 10 amps. Okay, we're not ever going to mess with this setting. There's nothing that we're going to do that is going to be up at that setting, so don't worry about that. Most of our amperages are going to be set either here or here, maybe the 200 milliamps maximum. Okay, but you'll never need to deviate amperages out of those 3 slots. But here's why I had you measure or buy 2 multimeters, because when you're measuring amperage and when you're measuring voltage, you are operating your multimeter in different ways. Okay, you're using your multimeter for different things, and many multimeters are set so that when you're measuring voltage, the internal resistance of the multimeter is very, very low. And so if you accidentally measure voltage or make a voltage type measurement, it can blow fuses, and it's a very big problem. It can be difficult to get to the fuse. It takes time. You have to buy a fuse and all that kind of thing. So it's easier from the outset to simply dedicate one of your multimeters to current, one of your multimeters to voltage, and you should be then good to go. Okay? So at this point, your leads on your multimeter, and I'm going to use this as my my amperage. Okay, I'm going to use that meter as my amperage. You have these needles, and so I'm going to then connect another set of gator clips, one to the positive here, and one to the negative here. And in fact, I might use this box to try and prop the multimeter up. So we can see what's going on here. So let's see if I can get this set up. I don't know if it's going to work. Good enough for government work, right? Okay, so let's be very clear about what we just did. I've now hooked a gator clip to my positive terminal on my multimeter, and I have hooked a second gator clip to the negative terminal on my gator clip, or on my multimeter probe. So now what I want to do is keep these as separated as possible. I want to now connect the negative lead on my multimeter to the jumper that is sticking into the negative slot on the breadboard, right? And then I want to do the same thing. Too much torque from the wires. So then I want to do the same thing with the positive, okay? And that is going to hook right here. And you'll notice, okay, that immediately my multimeter starts to read 15.6. And since I'm on the 200M setting, okay, this would be 15.6 milliamps, all right? 15.6 milliamps. And in fact, let me put this down here, and if I set it down to the 20 to get one more decimal place, then it's 14.51 or so milliamps. Okay? So that is your first data point. You have now measured your first data point. You have a source of voltage. Clear that one out of the way. You have a source of voltage. That voltage, as convoluted as this path is, it still is just a simple, complete path. You have a connection from your positive terminal of your battery into the positive part of your breadboard, which is then supplying a current through your resistor, and that current is then going through your multimeter. And you always want to put your current multimeter in series. Okay? You want to make your current multimeter part of the path. To use your voltmeter, I'll show you guys what to do here in just a moment for that. But to use your voltmeter, you actually want to put your leads here across the object you're measuring. So since I know that this should be a very small amount of voltage, I'm actually going to put this on 200 millivolts and set these beside each other. The box is twisted. Yikes. Let me see if I can get this. Alright. If this doesn't work, we'll do this one at a time. Alright. Well, in any case, you can see the volt, or the amperage reading there. So now we'll set the voltmeter up, and so now I have the leads from my voltmeter. We'll just set these in, and then I'll hold the meter up, right? And so all I need to do is touch the positive probe on my voltmeter to the positive end of my battery. I'm just going to stick it in there with the gator clip, and then do the same thing down here, and you'll see that I'm reading a number. Okay, in this case 1602, but I'm on the 2000 milliamp voltage setting, so this is reading 1602 millivolts. Okay, 1602 millivolts, or 1.602 volts. So if I were to set this to the 20 volt setting, then I get 1.60. Right? I would encourage you to, as far as this scale will let you, to use the more decimal points, because it'll be slightly more accurate. But there you go. So now your next data point, and this is going to be for the Ohm's Law lab, and the procedure will be online shortly. The next step is to then increase your voltage. Okay, I want to increase my voltage. So what I'm going to do is I'm going to unhook the negative lead off of my voltmeter, set it gently to the side. I'll figure out a better way to prop those up for the next video, so that way things aren't so convoluted. But disconnect your negative wire from your negative terminal of your battery, and your battery holders can connect by sliding together. Okay? Your battery holders can connect by sliding together, and as long as the metal in between the two connectors is touching, I should now have a larger amount of voltage. And you'll notice that now, since I've broken my circuit, my ammeter is also reading 0. So I'm going to reconnect my negative, and now you'll see that my ammeter is at 1, and that means that the scale is too much. There's too much current to read at the 20 milliamp setting, so I'm going to go up to the 200 milliamp setting, and now I'm reading 31.3 or 31.4, right, milliamps. And to get the voltage, reinsert your leads from the voltmeter here and here. Oop. And again, I'm getting a 1, which means the scale is too small. So I'm going to switch to the 20, and I'm reading 3.2. Okay? So now I have a current of 31.4 milliamps and a voltage of 3.19 volts. So you can then continue that process by adding in more and more batteries to get voltage and current measurements, okay? And as you do so, you can then build a table and plot your voltage against your current, and you can then verify Ohm's law graphically. That is what the procedure is going to do, okay? So this looks like a little bit of a mess, and don't worry if it takes a little bit of getting used to, but I would watch this video a couple of different times, right? Especially getting the setup of the breadboard correct. The convoluted part is how all of the gator clips and the probe wires, because they're so long, it just looks convoluted. If these were a bit shorter, it wouldn't be quite so bad, but just because they're long, they look kind of tangled and things. But the meat of what's happening is that you have a direct circuit, you have a direct path of current that is flowing through your resistor into your ammeter and then back into your batteries, okay? Even though it looks a little funky, that's what's happening. And the point is that we want to confirm Ohm's law, that there is a linear relationship between voltage and current, and that we can then use that to measure the resistance. Okay, so we know what the resistance is stated as, then we can measure the resistance and we can compare our measurement with the stated value. Okay, so that's what the goal is for verifying Ohm's law. Then in the next few labs, we'll build a few more elaborate circuits with series and parallel and with Kirchhoff's laws. And then we'll do some things with some capacitors and RC circuits. And so that is where we're going to be headed. But the basic idea, once you learn how to set your breadboard up, it will be much easier and intuitive to visualize, okay? But I did want to make this video for you guys to show you how to set it up. Then to finish the lab, just keep adding more and more batteries to your pack here and extending the supply of those batteries to the circuit, and you should see increases in your numbers. You can make a data table, and we'll do the analysis in Excel. All right, so the procedure will be up shortly, but I wanted to get this shot for you guys to show you how to set it up. All right, we'll talk to you all later.